Hello, aspirants! Today, let me take you on a fascinating journey through Chapter 2, the origin and evolution of the Earth. This is a crucial topic for UPSC and MPSC, and understanding it gives you a strong foundation for geography and science. Let's begin with the basics. Earth's origin and evolution help you understand how geological processes, the atmosphere, oceans, and life itself came into existence. Remember, Earth is just one of 8 planets in our solar system. Theories about our planet's origin are divided into early ideas, both mythological and scientific, and modern theories like the Big Bang and solar nebula hypothesis. In ancient times, people explained the Earth's creation with stories and myths. But as science progressed, more systematic theories emerged. The nebular hypothesis by Kant and Laplace in the 18th century suggested that the sun and planets formed from a spinning cloud of gas and dust. As it cooled and spun faster, rings separated and became planets. However, this theory couldn't explain why planets and the sun have different angular momentum. Then came the Tidal hypothesis by Chamberlain and Moulton, which proposed that a passing star pulled out matter from the sun, which later formed planets. But such a close encounter is extremely rare. Another idea, the binary star hypothesis, imagined that another sun-like star interacted with our sun, giving rise to Earth. Now let's move to modern theories. The Big Bang theory, introduced by Edwin Hubble in the 1920s, is the most widely accepted explanation for the universe's origin. About 13.7 billion years ago, the universe began from a tiny, hot, and dense singularity. It suddenly expanded, cooled, and formed matter. Eventually, this led to galaxies, stars, and planets. Key evidence for the Big Bang includes the redshift of galaxies, which shows they are moving away from us, and the cosmic microwave background radiation, the leftover glow from the Big Bang. The abundance of hydrogen and helium also supports this theory. After about 1 billion years, galaxies like the Milky Way started to form. Our galaxy is roughly 13.2 billion years old. Stars formed when huge clouds of hydrogen gas collapsed under their own gravity, leading to nuclear fusion. Depending on their mass, stars could become red dwarfs, explode as supernovae, or even become black holes. The solar nebula hypothesis explains how our solar system formed. The sun was born from a rotating cloud of gas and dust called the solar nebula. The remaining matter flattened into a disk, and dust particles combined to form planetesimals. These merged to become protoplanets, which then evolved into the 8 planets we know today. The age of the Earth has been determined using radioactive dating, about 4.6 billion years old. Earth's structure formed in stages. Heavy materials like iron and nickel sank to form the core, while lighter materials formed the crust and mantle. This led to a layered structure: core, mantle, and crust. As the planet cooled, its outer layer solidified to form the lithosphere. The atmosphere evolved in 3 stages. First, hydrogen and helium dominated but were lost to space. The second atmosphere came from volcanic gases: water vapor, carbon dioxide, and nitrogen, but no oxygen. Oceans formed as water vapor condensed. Later, photosynthetic organisms released oxygen, creating our current oxygen-rich atmosphere. Life on Earth likely began about 3.8 billion years ago in the primordial oceans. Energy from lightning, UV rays, and volcanic activity triggered the formation of organic molecules, which eventually led to self-replicating cells. Here are some key facts for your revision. Earth's age is 4.6 billion years, the universe is 13.7 billion years old, and the Milky Way is about 13.2 billion years old. The atmosphere evolved from hydrogen-helium to volcanic gases to oxygen-rich due to photosynthesis. The Big Bang is supported by cosmic microwave background radiation. Our solar system formed around 4.6 billion years ago, and life began about 3.8 billion years back. To conclude, Chapter 2 gives you the scientific basis of the Earth's and universe's origin. It helps you understand the Earth's geological structure, the formation of the atmosphere and oceans, and the emergence of life itself. This is essential for UPSC GS1 and GS3, MPSC, and other state exams. Keep revising, stay curious, and all the best for your exams.